Hello everybody, this is Cristian Benavides, and in this video I'm going to show you some of the features of the collision system that I've been working on in the first month of engine development for our final project game. So I'm going to go to the gameplay, and there I'm going to show you one by one the features of the of the collision system. So let's see it here. So basically, all entities in our game have bounding volumes. Those bounding volumes are represented here as the gray sphere you can notice that is around the enemies and the spawn points and the player. They're not just spheres, they can also be AABBs. You can notice that the spawn point has an AABB, a box around it, an axis aligned bounding volume. So basically, those gray bounding volumes are used to detect bound overlap between entities. So for detecting collision between all the entities, we're using a layer system that is actually reducing a lot of pairwise tests. All entities are organized in layers. The dinosaurs are in the layer of enemies, the spawn points are in the layer of levels, the players in the player layer. That way, when we're checking collision between all the entities, we'll check first, okay, should I check collision between the enemies layer and the level layer for spawn points? And there's no need for that, so we just don't do collision tests, and that's actually saving us a lot, because we don't want to check all these dinosaurs or like 10 dinosaurs against all the spawn points, right? There's no need for that, and vice versa, we don't want to check all the 6 spawn points with all the 10 dinosaurs. That's basically the layer system that we're using for our game, for collision detection. Another cool feature that we have right now, it's the Frustum culling. So if something's not in the screen, it's not going to be rendered. You notice that right now the game is lagging a little bit, but as soon as I look the other way, boom, the game goes faster, goes perfectly fine. Look at there, it's lagging. So what we're doing is that we have our view Frustum that has 6 planes, so we are checking collision between all the entities. We're checking if all the entities are inside this frustum. If they're not inside, they're not going to be rendered. And that's a huge optimization, as you can notice here. Right now we're only rendering this part of the terrain. Well, actually the whole terrain, we're thinking how to cool some parts of the terrain. We're only rendering the player, and that's it. I don't want to turn back again because that's gonna lag a lot. Or will it? Oh no, because okay, I'm not rendering the debug data, so that's cool. So, by the way, the game was going a little bit slow because we're in debug mode, so it doesn't lag at all in release. It's only for testing sakes. Ooh, yeah, you see, everything goes a little bit crazy. So yeah, that's a Frustum culling. We're very proud of that. So the other feature of our game that we're very proud of. Let me kill some dinosaurs. Well, there's no need for that. Let me just restart again. Another feature we're proud of is the proxy geometry. As you can notice, the player and the dinosaurs have the gray bounding volume, and they also have the blue spheres. That's what we call the inner bounding volumes. So what's happening is that for more accurate collision, instead of just testing collision between the ray and the gray bounding volumes, as you can notice, it's not very precise. I mean, if I shoot there, I'm not actually shooting the dinosaurs. That's why we have the blue ones. The blue ones are actually attached to the joints of the model, as you can see in the player. So the difference between these two is that the gray bounding volumes are made based on the model of the mesh, the model of the entity, sorry, the mesh. For example, the AABBs, we're finding the highest X, Y, and Z, and the lowest X, Y, and Z, and then we're making a box from it. In the sphere, we're finding the center of the model, and then finding the point that it's farthest, and that will be the radius of the sphere. And that's not very accurate, right? We're just defining a bounding volume that's saying, hey, he's approximately occupying this space in the world. So what we're doing is that we're using that proxy geometry to then test against the blue spheres. So let's say the ray actually collides. Let me just zoom in. So let's say the ray actually collides with the gray sphere. Then we're gonna check if the ray is colliding with any of the blue spheres of the dinosaur. So look at this. I'm actually shooting outside, nothing's happening, but as soon as I shoot to the blue ones, he's taking damage. So we're very proud of it. These blue spheres, as I said before, they are attached to the joints of the dinosaur and the player, of the joints of the animated model. But the thing is, we have our own in-engine tool to size them manually and also delete some of them, because in some cases you don't want to check collision between the ray and, let's say, the fingernail of the dinosaur, right? These dinosaurs have 48 joints, which is a lot, and we don't need them all to check collisions with. So let me show you our in-engine tool, which we are very proud of too. Here we have it. Here's the player right now. It has all its joints, and you can perfectly go through all the joints. I need to fix this though. You can just go through all the joints and scale them at the same time. You can just go through one of them and scale them separately, as you can notice. You can delete some of them, as I explained before, because we don't need them all, and that's, if you have less colliders, it's easy to make collision tests. Only has one. Yeah. So this tool is actually very good. We can decide to save or not. You can reload all of them if you don't like what you have. So this is actually making us have very precise collisions, which we are happy. We're very happy for it. We're thinking of, instead of making spheres, we're gonna make capsules, but for now it's working very good with all the spheres. If we need to change, we'll change it. It's gonna look better. I still want to add more functionality to this, but we'll see how time works with us. But yeah, that's what we have. Let me do something very fast. I'll just trim this later. Okay, so look at this. Right now I'm gonna delete all of them so you can see how the tool is working, that it actually works. I'm just getting this, I'm gonna size it up properly. Let's just put it very small. This is the sphere in the gun. So I'm gonna save, pressing enter, and I'm gonna leave the screen. I'm gonna go back to the game, and you can notice, boom, there you go. That's the only inner bounding volume that the player has. So the tool is working very good. We're saving everything to a binary file and then reading it when we load the prefab. Oh yeah, we're using prefabs. Thank you, Unity. Okay, so that's basically it, right? That's basically it for the geometry, for the collision detection. Now, the other awesome part I'm very proud of, and I think we are very proud of, is the ground clamping. As you notice, the player is following the terrain surface. It's not just going through it, it's actually going down and up. It's not clamped to any Y, it's actually always in the surface of the terrain. So what we're doing here is that we're finding the collision point between the player and the terrain, and then we're assigning its Y position to that of the collision point, since the origin of the entities are in their bottom. So the way we're doing this is that we're casting a ray from the top of the player pointing down in the world's up direction, and then we'll find the collision point by testing the ray against the mesh of the terrain. The problem comes though when we're actually, if you notice the mesh of the terrain, there are a lot of triangles. I mean, there are 20k triangles in this model of the terrain. So that's a problem, right? Because we're testing all dinosaurs. All dinosaurs are being ground clamped, as you can notice. Look at that. They're being ground clamped. So that means all of them are casting a ray every frame. And if there's no special partitioning technique or anything, we're testing, like, let's say 15 rays against 20,000 triangles every frame. That's a lot. That's like more of 200,000 tests every frame. So the way to prevent this is we're using a BVH, a bounding volume hierarchy, to divide the triangles of the terrain mesh. So the way this works is that we're dividing the triangles of the terrain mesh in different bounding volumes. In this case, there are AABBs. So we're just dividing half every bounding volume of a terrain, and then we're only testing the ray against triangles that are near it. So let's look at it this way. We're getting the whole terrain mesh, we're dividing it half. Then those two halves, we're dividing them in other two halves. And then we're just going that way until we get to an ABB that only contains like 3 to 2 triangles. And then to get those triangles, we're getting the ray. It's going through all those bounding volumes, just checking if it's actually inside of them, and until it gets to a leaf, if it gets to a leaf that has the triangles, and we're testing the ray against those triangles. It can be a little bit complex if you're not very familiar with these terms. If you have any questions, just feel free to message me or ask any questions or put something in the comments. But it's pretty awesome and it works perfectly. So now we're testing the ray against only 3 triangles at max. Yes, and we're doing that per entity, and you notice that the game is running pretty good. The lag that we're having right now is because it's in debug mode and it's the rendering of the debug data basically. But yeah, I think I covered everything. Yes, so yeah, bounding volumes, inner bounding volumes, outer bounding volumes, ground clamping, Frustum cooling, and layer system for collision detection. Yeah, that's basically it. Thank you for watching the video. If you are interested in watching more videos, you can just go to crispygames.com and you'll find more of my work there and more information about our Fire project. You can also follow me in my YouTube channel, Crispy Games, and you will find more of these videos of my work. Thank you. Any feedback is highly appreciated, and hope to see you around. Yeah, thank you.